get a better life. And every conscious activity was processed by at the surface area in the brain. So actually the our ultimate goal is we have to establish the analytical method for the human brain in daily life. And the subject is the development of natural and high performance measurement method is necessary to understand the human brain function. So I will introduce the principle and the history of the optical topography in next chapter. And we are using the near-infrared light to measure the human brain function. This photograph, from the opposite side of this palm, I irradiate the white light. But you can see the just red light. This means the red light can easily penetrate the human tissue. So red light can penetrate the deeper area in the human body. So we use the red light to measure the brain function. Actually, visible red light is the wavelength of the visible red light under 700 nanometer. And in this measurement, we are using a little bit longer wavelength than the 700 nanometer. And this is the most high permeability against the human tissue. So this technique is also used for the Venus pattern authentication installed in the bank machine, etc. And this graph, horizontal axis means the light wavelengths, and vertical axis means absorption of the hemoglobin. And hemoglobin is included in red blood cell in your blood, and the blood cell contents is 40% to 50% of blood. And there are two kinds of the hemoglobin. One is the oxygenated hemoglobin, and it is very rich after lung circulation, and the color is very clear red. And the second type of the hemoglobin is a deoxygenated hemoglobin. It's very rich before lung circulation, so the color is dark red. And we are using around 800 nanometer wavelengths, and we use two wavelengths because we have two kinds of hemoglobin, and each hemoglobin has a different absorption curve for the wavelengths. And if we use the two wavelengths, we can measure the concentration of the oxygenated hemoglobin and deoxygenated hemoglobin in the blood. So finally, we can determine the oxygenated hemoglobin, the concentration of the deoxygenated hemoglobin using the two wavelengths around the near-infrared light regions. And so if simply say near-infrared light can measure the color difference of hemoglobin. And the color is really the activity. I think the color is the activity of life. For example, the activity of life is maintained by oxygen metabolism, and oxygen metabolism is depend on the chromoprotein like the hemoglobin and also chlorophyll in this leaf. And many chromoprotein consist of the porphyrins. Porphyrins is this pink chemical structure. And porphyrin has many coupling of a double bond like here, and the double bond absorbs the specific wavelengths of light. That is the meaning of using the near-infrared light. Okay. And therefore, the leaf and blood and muscle show special colors. And the optical measurement method of color changes has been developed in order to understand the activity of light since over 100 years ago. Now, before development of the optical topography system, we calculate how the photon can penetrate from the skin to the brain. So this is one example of the photon pass from the irradiator to the detector. So you can see the photon can reach at the surface of the brain. I will show again, like that. Amazingly, I set the irradiation optical fiber at the surface of the skin and separate from this optical fiber the distance between from the irradiation fiber to the detection fiber was 30 millimeter. In that case, the traveling length is about 150 millimeters, so very long. And finally, we simulated if I simulated a lot of photons in the brain. So this figure shows the simulated result, and I input 1,000 photons from the skin. Then finally we got about 0.1 photons here. But you can see the banana shape distribution in the brain. This is the probing area of the brain function. So maybe you have some questions. Light can penetrate the skull. Skull is very hard, hard substances, and after the stimulation, we check the light can penetrate or not. Light can penetrate the skull or not. And this is a real human skull, and we irradiate the near-infrared light from the opposite side. And you can see very clear light from this side. And